Hello. My name is actually Igor Artamanov. There's a mistake. So as Anthony said, I'm going to talk about our solution to sidechains. It's not quite right, actually. So I was thinking a long time what I'm going to talk about. And this morning, about 7 a.m., I finished my slides and just going to educate, kind of educate about what sidechains and why exactly sidechains. And a little bit about what we are working on. So I'm Igor Artamanov. I'm a software engineer, and I'm a founder of ETCDEV. I was with Ethereum Classic since the beginning, since the DAO fork, and yeah, found ETCDEV team. So first question, why we need sidechains? Why so many people talking about this? Because mainnet is slow and it's also expensive to execute, which is kind of same thing, right? So like I just looked at ETH yesterday, I think, and the top 5 apps on ETH are using 40% of the network. So, or CryptoKitties, I think the only one application that makes sense on ETH uses 2% of the mainnet. So you can run like 50 CryptoKitties, 50 the apps. How many websites do we have? I think like millions, tens of millions. If you're building blockchain for people, it shouldn't be limited to 50 applications, right? So yeah, we can't use mainnet at the current state for building the apps. It's too limited for that. And that the problem of scalability is the biggest problem everyone is trying to solve at this moment. All blockchains and a lot of researches, many solutions. And I think there are kind of 2 types of solutions to scale issues. One of them I would call vertical scale, another one is horizontal scale. And I'll show you some examples to understand what it is. So vertical scale, basically you have, see this? That's when you just upgrading your computer, adding more memory, and more CPUs, and so on. It's going to be expensive. Each step is going to be more expensive than the previous one. And at some point, you'll reach some, I don't know, super fast computer you can't upgrade anymore. And there is basically another way, just buying the same computers more and more and putting them together to work together. That's a horizontal scale. So vertical scale, when we're upgrading our computer, there's 2 ways again. So we increase throughput, which means we just upgrading our computer, like make it faster. But we can't increase block size for Ethereum, or gas limit size. Because with current gas limits, it's already too expensive to operate the network. You need really powerful computer at this moment already to use mainnet. And most people don't have enough powerful computer laptop to use, so they just rely on some other systems like Miser Wallet, Gas Tracker, or whatever, which is, again, a centralization. And there is one example, just a couple of days ago, right? There is some event, ETH Berlin, and like even judges, they didn't have sync mainnet now. Yeah, I think it was kind of a joke. I don't know. Maybe that's true. It was a problem. I don't know. But that's an example. What's going on with the mainnet. The same for both Ethereums, ETH, ETC. It doesn't matter. Technology at this moment is the same. So we can just increase gas limit and expect it will work faster. It will work slower, actually, and it will be more centralized. OK, you could probably optimize throughput, like make the network faster. I don't know, optimize EVM or some software. So with current gas limits, with current block size and everything, it will work faster. Yes, we can, but that's not the problem we want to solve, actually. So my point that we have like centralized solutions and decentralized solutions, right? And like one side, if you're talking about execution, code execution, one side will be like a Kafka running on my server, another one will be C blockchain, and between them some, I don't know, Amazon, AWS service, or whatever. If you're talking about money, one side will be Bitcoin, another side will be cash, and in between will be some bank software. So we have centralized, decentralized, and there is two variables. One of them, the performance, is going down, and I don't know how to call this green line, transaction finality or something, but this is variable we're trying to improve. And they kind of opposite. And actually, it doesn't exist. It just started at some point when we got blockchain. Because there is no like finality with a bank or with someone's server. There is no guarantees at all. You can't trust them. But that's what we're trying to improve. That's what we're working on ETCDEV and on ETC. We are pushing these boundaries. And we're pushing it from to improve transaction finality, immutability, whatever, like main blockchain features. It becomes slower. It becomes more expensive to execute. And yeah, so speaking about improvement, yes, if you move that to the left, yeah, you can make it faster. But you're losing some features of blockchain. There are a lot of examples in blockchain space when you have like a centralized server, which actually competing with Kafka or some software, centralized server. They don't provide any centralization, any transaction finality. And by transaction finality, what I mean? I mean that there is no government, no big corporation, or criminals that can reverse transaction and force someone to reverse transactions. You know, criminals can make an offer you can't refuse. So there shouldn't be a way to do that. And that's what we're doing in ETCDEV and ETC. We are making blockchain that will be impossible to revert. So that's our goal. So it seems that vertical scalability is impossible when we want to keep the main network secure and decentralized. And that's what we're trying to make. That's our main goal. OK, we have a horizontal scale. And this is basically sidechains. Sidechains is an old idea discussed in Bitcoin talk and everywhere for many years. Like, I mean, in blockchain space, it's an old idea, like a few years. Okay, so it's like there's two layers. Layer 1 is my secure network, mainnet, and layer 2, a layer above or behind layer 1, which can be less secure because it's just for temporal state. And basically, you're using security from mainnet. So that's sidechains. And there's basically some laws from 60s. Yeah, I mean, it's applicable to blockchain too. So everyone understands this, actually. Right? So if you have less shared state, you can scale it. So if you have one transaction mainnet and everything else in sidechain, you can scale it much better than some application that uses blockchain mainnet for everything. right? So we think that sidechain use is still secure, but less expensive because it's not proof of work, and it can be centralized more or less, like for your service. You can make it centralized, but because you don't really care about results after the moment when it's secured in the mainnet. And mainnet is something to finalize your state. And there are many existing projects, all different ways. Some of them is not necessarily sidechains, and there is much more than 6. I don't know. It's like, I don't know, maybe 20 of them. I just pick random sidechains like Lightning Network for Bitcoin, Raiden, Plasma, Loom for Ethereum, and Polkadot-Cosmos, a little bit different stuff, but still can be considered as a sidechain. And it's okay to have many solutions to the same problem, and especially if you use the same technology, base technology as Ethereum. So be at Ethereum ETCDEV have own solution to sidechain scalability problem, and all developing on idea of sidechains. And we just calling it sidechains for a long time. Recently, we decided to make some name for it because it's just easier to discuss. So we call it Arbita now. So basically, we want to run the apps on Arbitas. And that's a shiny logotype of Arbita project. So what exactly we're working on Arbita? So it's just a programming interface, kind of ERC20 for tokens, the same for sidechains. Standardized interfaces, APIs, whatever. It's not a new blockchain or change to existing blockchain. So we're thinking about adding some new features to mainnet, maybe. We're trying to avoid that. We're trying to make it just on smart contract level, but there is some limitations, so we're researching the exact way how it's going to be implemented. And actual implementation, we want to live outside of the scope. So we want to provide just examples, like ERC20. There is some examples of token, but you can implement whatever you want. Just follow the common interfaces, which will be supported by other services, providers, exchanges, wallets, whatever. So the same for our Arbita. We want to provide some interface. So developers will follow that interface, services, and all the apps and everything can communicate through that same interface. Also, we're going to make a documentation specification. That's the most critical part, right? So developers should use some reference manual, some specification to make the apps so they can work together. And yes, we need to make some tools, base tools, basic components, basic implementations, examples, some tools to launch the app to an Arbita, and tools to connect Arbitas, the apps, whatever. But again, we want to make an example. We don't to make like some final standard everyone must follow, like and no step on side. So key features about security. So we think that proof of work is secure enough for mainnet. We are not touching it. But we can't use probably proof of work for an Arbita. It's expensive. So we are looking at kind of implementation of proof of authority, proof of stake for an Orbiter. And again, it's interface-based, so it does matter. You can implement whatever you want for your Orbiter. But we're going to base our documentation materials and examples based on proof of authority and proof of stake. Proof of authority, basically a trust environment for your single app, maybe it's going to work. And it can work because it's cheap to execute. And yeah, we're going to use a parent network for stakes or whatever. It can be secure enough. And we want to give every app a separate Orbiter. That's kind of our goal. So use mainnet only for state synchronization, nothing else, or some cross transactions. So there's 3 main companies we're working on. First of all is Checkpoint on a mainnet, from Orbiter to mainnet for security. Second one is how you read between Orbiters. And yeah, so if you run every day up a new sidechain, a new Orbiter, the app still needs to communicate to each other. They need to read from the app, from one smart contract in one Orbiter to another Orbiter, and sometimes write. So there's 2 ways and 2 solutions. One for read access, another one for write access. So for read access, we're researching oracles-based pattern. And for write access, we're researching atomic swaps pattern. That's kind of example of a checkpoint or Orbiter's smart contract on mainnet. It's some unified interface to discover new Orbiters, read chain configuration from some IPFS or HTTP, find bootstrap nodes to connect and synchronize the state, some latest checkpoints, history of checkpoints, and some information of services deployed on that Orbiter. And again, so there could be unified services deployed maybe on every Orbiter for name service or for other stuff. So it should be supported by Orbiter. So when your wallet connects to an Orbiter, it should find the services. And it should be configured in some way. As I mentioned a couple of times, checkpoints. So checkpoint basically when you finalize your state, your current state, into a more secure network. And yeah, that's the basic idea of sidechains, I think. But what's important for checkpoint? For checkpoints, it's most important that nobody can revert this checkpoint from a mainnet. And I think that's only ETC and Bitcoin maybe. I mean, if it would support smart contracts, can be that layer, that secure layer. On Ethereum ETH, you can't make sidechains basically because the Ethereum Foundation can revert these checkpoints, and they revert the state of sidechain too. So that makes sense. So we consider ETC as the only secure layer for that. And as I mentioned, oracles for read access from one Orbiter to another one. So we are working on some kind of market system for this read access. And yes, atomic swaps to make write operations from one to another one. There's a few examples. Again, we are looking at them, making experiments. There's one piece relay that's going to be discussed tomorrow, I think. And so other examples for this kind of communications between different chains. So we consider this as a way to communicate between Orbiters. And but I think it's most complicated, actually. That's what would be hard to integrate this Orbiter in every user application, user-facing application, in wallets, explorers, and everything. There should be a unified way to identify all these Orbiters and explore them and avoid any problems, like make replay protection and everything. It should be clear for user that what he's using exactly. There's other elements that we are working at this moment. So there's naming, schema, navigation, whatever. And now about roadmap. I need to mention that, so we started to work on sidechains, really started to work, I think, like half a year ago only. Because, we are a small team. It's 14 people now. And we have a lot of projects to work on, and basically don't have enough time to work on everything. And this was a kind of part-time project for us, on free time, for one developer to make experiments, and we want to expand the team to work and focus more on Arbitas because it's the most important task for us. But still, we need to work on our Emerald projects, on wallets, on Get, and Sputnik VM, and everything. So I don't can provide any exact dates, and don't expect that it's a quick project. It's the biggest project. All blockchain projects are working on sidechains, and it could take years to make it production ready. So maybe we'll get some prototype working soon, but I don't know dates. I can't say anything. Yeah. But anyway, it's the current state that we're working on some prototypes. One of them, Sidekick. You can find it on GitHub, basically an experimental sidechain Arbiter. It was working, so we also integrated proof of authority, consensus configuration to classic Get, and we consider this a first experimental network, Arbiter. The current implementation is not really user-friendly. It's not even developer-friendly. You need to make a lot of hacks to make it working. So next step would be make it more friendly for developers and make some operations between different sidechains, between different Arbitas, which is very complicated, as I say. And we are looking for pilot projects. One of them is a pilot project with OpenStack, which is decentralized cloud provider. And they were interested. We're looking for decentralized blockchain to make the OpenStack passport program, and they contact us. So we're trying to make a working solution together with them. And OpenStack, yeah, it's a big company. We mentioned them a couple of times today. So many companies are using OpenStack technology, and that means that if you make something working, it will be tested very seriously. After that, we need to make some read access between Arbitas, make a proof of stake Arbita, which is much more complicated than proof of authority. Proof of authority Arbita is basically when you trust some nodes which are running your Arbita. It could work for some applications, but for most of the public applications, we consider some market of proof of stake nodes and miners, block validators, which will make stake on the mainnet, of course, and will produce some blocks on your Arbita. And we'll need to integrate into Emerald Stack wallet and all tools and all companies and everything. Thank you. That's basically all over you. I don't know if you have time. Yeah?
All right. Does anyone have any questions about Orbita? Come on. Okay, I have two questions.
Mm-hmm.
So first question is, what kind of capabilities do you think Orbita is going to have in terms of maybe throughput? Is it comparable to like a SQL, or is it maybe how many transactions per second do you think you'll be able to push through it?
For that slide,
However you want to take
you know, that slide, first one, like one is the first one with its true performance and everything. Yeah, it will be more like on a left side. And as I mentioned, because yeah, it can be trusted environment or something, so you can choose that, but you finalize your state on a mainnet. So you can optimize on sidechain, but you can optimize mainnet because we're trying to optimize for a different variable. But for sidechain, for Orbita, you can optimize for performance. And
then, since you're going to be more on the left side, you're going to be able to still get finality if you want by committing back to the main chain, basically.
Yeah.
Is that right?
Yeah.
Okay.
Yeah, yeah. And that would be a part of your consensus on your Orbita. So if like all Orbita participants can verify and will verify that this block was actually committed to mainnet.
Great. And do you think for Orbitas, is there any possibility that they may be cross-Orbita communication as well, or is there?
Yeah, that's what I said, these oracles to read from one Orbita to another Orbita and without using mainnet. And to write access some cross swaps between Orbitas.
Okay.
Which again, we are going to provide some interfaces. And interface because we think it's infeasible to make some universal way to read and write every possible state. But you can optimize for some of applications, like for tokens, this kind of oracle or swaps between chains. And for another application, it will be different implementation, just following same interfaces. So you can optimize for your particular application, for your particular Orbitas, what you're going to read and write.
Okay, yeah, great. Sounds really good. Oh, got a question over there. Oh, I'll just come over.
Thanks, Igor. So sidechains were a frequent topic of discussion today, and I'm wondering what your view is on whether all these sidechains will be fully compatible with one another, and how we can make it easy for users to select the sidechain that kind of fits their particular use case. Because I could imagine, being a user and looking at all these different sidechain options and not necessarily knowing which one optimizes for my particular business or individual use case. And so I think making it easy for people to understand that is something that's of the utmost importance.
Yeah, I mentioned that it's going to be more like interfaces, and we expect that developers will choose some implementation that will work better for them. Block size limits, some consensus options, or whatever. And we want to make it flexible as much as possible and configurable. And speaking about users, it depends what do you mean by users. So if end users, it should be hidden actually from end users. They shouldn't care. They should just start using the app, and it's. But developers, they should have a choice and some way to make most optimal Orbita for their app. So we mostly targeting these developers and want to provide these most flexible tools for them.
All right, great. So now we're going to have a cocktail reception. You're going to just exit here, go up, take the elevators up, go out the front door, and it's going to be outside on your left. Thank you very much to Igor Artamanov.